Now, how do we remove an item from a heap? Okay, well, removing an item from the heap, you can only remove an item from a heap in one way, and that's by removing the root of the heap. Or removing the root of the tree. Okay, so you don't ever remove something. You don't remove something here. We only focus on ever really removing the root of the heap. Okay, so let's go ahead. So we can remove the item from the root by replacing it with the last item in the heap. So say we need to remove 6 from the heap. What we do is we take 66, move it up here. So we move it up and replace it, right? See how that moved up. And now, of course, the heap structure has been violated because we just moved something that was pretty heavy to the top. So again, like I repeated in the last video, lighter items float to the top, bigger items sink down. So 66 is pretty heavy, so it needs to sink down as far as it can. So now that gives us the second line. While the last item in the heap has children, and it's larger than either of its children, so while 66 is is bigger than either of its children, swap it with the smaller child, right? So we're bigger than 18 and 8, but 8 is the lightest, so it needs to bubble. It needs to bubble to the top, so we swap with it. So now we look at our children, 29 and 39. We're bigger than both of those. We'll swap with 29. And then I basically hit bedrock, so I'm done sinking. It's fairly straightforward to do that. So let's go ahead and see what would happen if I were to remove another thing. Let's go with let's go with this. So let's go ahead and say we wanted to remove another item. We'd remove 8. Okay. Right, we'd remove 8, and we'd move 89 up there. So 8. Move 89 up here. So now 89 needs to sink to the bottom. Okay, so 89 is heavier than both 18 and 29 because it's bigger than both of those. So we're going to swap it with the lighter item. So we're going to move 18 over here because that's the smaller of the two children, and 89 goes here. Okay, now 89 is still bigger than both of its children, so we swap it with the smaller of its children. So 89 will go here, and 20 ends up being over here. 89 is bigger than both of its children, so we swap it with the smaller child, which is 26. So 26 would go here, and 89 would go here. So our heap would look like 18, 20, 29, 26, 28, 39, 66, 37, 89, 76, 32, 74. And if we look at this, it's still the heap property because of these operations and these swaps has been maintained, right? 18 is the smallest item in the resulting heap. Let me just blotch these a bit more. 18 is the smallest item in the heap. 20 is the smallest in its own subheap. 26 is the smallest in its own subtree. And right, 89 has basically hit bedrock.